Hello everyone, and welcome to another video presentation, courtesy of the University of North Texas Physics Department, with the assistance of the Physics Demo Room. My name is Corey Nook, and today we're going to be talking about Archimedes' principle, in particular, the application of buoyant forces. So a buoyant force, a lot of us might have experienced either while having a bath in a bathtub, or going to a local swimming pool and swimming and playing with different objects underwater. A buoyant force allows us to say that the act of water or the amount of volume displaced by an object in water, the water is going to push back up and make it appear like it's not as heavy or there's not as much force caused by that object. And that just has to deal with the amount of volume that the object displaced, as well as its mass. So with this demonstration, what we're going to say is, well, how do we actually calculate this? So what we have set up today is we have 500 gram mass, we have a dual range force sensor, which is going to act just like our scale. A scale gives you your weight, which is your force, which is going to be in pounds, which is your mass times gravity. We have some string to attach it, and we have a tub of water to tell us what the mass is before we put it in water and afterwards, and you'll hopefully see it on the screen. So if you notice on the screen now that our force acting on our sensor is close to zero. Right now I've added this string. It gives me about 0.01 newtons. So what I'm going to do is to zero this out again. That way it's closer. That way we shouldn't have any excess value due to the string. And now I'm going to hang my mass and hopefully have it not spin. So this 500 gram mass gives me about 1.5 newtons of force. So as we collect this, we see, okay, 1.5, that's our red line that we see right there. So now what I'm going to do, I'm going to move this string up just a little bit, that way I don't get too much excess in the water. I'm going to move the string up. I'm going to place it in the water, that way it's not hitting any of the sides. And we're going to take another collection of data. And we see that this collection is now 1.35. So we see here we have 1.35 instead of 1.5. So we reduced it by about 0.2 newtons, which is all going from how we see it with this Bernoulli's principle. Our tension reads the sensor, our weight, which is mass times gravity, pulls down, but while we're in water, we have this force pulling up. So this almost counteracts these two and allows us to have a reduced total force, which is why the sensor went from 1.5 newtons to about 1.35 newtons. Well, thank you all for watching this video presentation, and have a wonderful day.